Okay, today we're going to be talking about modeling using logarithms. So, I have pH equals negative log of H plus, where H plus represents the concentration of hydrogen ions. pH is used by chemists to measure the acidity of a solution. It is measured on a scale from 0 to 14. 7 is neutral. If pH is less than 7, it's acidic. And if pH is greater than 7, it's basic. So you do not have to copy these down because they're in your book. Page 433, number 33 says, the hydrogen ion concentration of a sample of each substance is given. Calculate the pH of the substance. So I want to know the pH, so I need to write the pH formula. The pH formula is pH equals negative log of H plus. Okay, so I want to know the pH, and I gave you the hydrogen ion concentration. So pH equals negative log of 3.2 times 10 to the negative 4. And this is to find the pH of tomato juice. So all I did was I plugged the amount of hydrogen ion concentration in to the hydrogen ion concentration spot. So negative log of 3.2, and to get that times 10 to the negative 4, you press second comma, and that gives you an E, negative 4. That means 3.2 times 10 to the negative 4. This is the way that you need to put it in there. You'll be practicing in class. Enter, and the pH is 3.5. And because this pH is less than 7, then it's acidic. That will be the only example of that kind I do on the video. I'll do more in class. Okay, page 433, number 35 says, the pH reading of a sample of each substance is given. Calculate the hydrogen ion concentration of each substance. So I'm talking about pH, so I need to use the pH formula. And this time I gave you pH and I want hydrogen ion concentration. So I plug in what I know. 6.5 equals negative log of H plus, does this say 6.5? All right, well, in order to solve this, I need to get the log by itself. I do that by dividing by negative 1 on both sides. And the good thing is these are solved the same way every time. And the log is not canceled out, just the negative. So negative 6.5 equals log of H plus. And now you're trying to solve a logarithm equation, a logarithmic equation, and there's not a log on both sides, so you have to turn it into an exponential. The understood base for a log, if it's not written, is 10. So you have 10 to the negative 6.5 power equals the hydrogen ion concentration. So H plus equals 10 to the negative 6.5. The wrong button. So 10 to the negative 6.5. And you get 3.16 times 10 to the negative 7. Now, this formula is done, this kind of problem is done the same way every time. And let's talk about it. pH equals negative log of H plus. And you wanted the H pluses. So I can get that by itself. All I have to do is divide by negative 1 to get the log by itself. So negative pH equals log of H plus. You want the H plus by itself, and you do not have a log on both sides, so you can't cancel it out. And you know that the common base is 10, and you do your cycle. So check this out. 10 to the negative pH power equals H plus. Well, look at this. you did 10 to the negative 6.5 power. 6.5 was the pH. This formula will solve that kind of question every time. Okay, now we're talking about Richter scale. Richter scale is a measurement used to compare earthquake magnitudes based on the formula R equals log of x over 0.001. R equals the Richter scale value, or the magnitude. X equals intensity, or the strength of a quake measured by a seismograph. So, page 433, number 41, says the Alaska earthquake of 1964 had a magnitude of 8.6 on the Richter scale. How many times more intense was this than the 1906 San Francisco earthquake? So, you know you're going to be using the Richter scale formula, which is above. And we are asking two different things. We're asking about Alaska and San Francisco. So I'm asking two different things, and I have to sit the microphone down, so I'll speak loudly. All right, we're talking about Alaska. So here's Alaska over here. I need to know how many times more intense was this than the San Francisco earthquake. Well, I don't know either intensity. I need to figure it out. So I gave you the R. I'm finding X. So I'm using this formula. All right. The magnitude of the Alaska earthquake was 8.6. So 8.6 equals log of X over 0.001. Okay? And I need to get that X by itself. Well, the log's already by itself, and it has a common base of 10. So I do my cycle. So 10 to the 8.6 power equals X over 0.001. And I need to get X by itself. So I have to multiply by 0.01 on both sides. So when you do that and you type that in your calculator, you get a very large number. You get the number 3. I'm recording the lesson. Okay. 398,107.17 is your X for Alaska. Very large number. Now I need to find my X for San Francisco. So San Fran, I'm doing the same thing. This time, the magnitude is 8.3. So 8.3 equals log of X over 0.001. All right, you know the understood base is 10, and you do your cycle. So 10 to the 8.3 power equals X over 0.001. You need to get X by itself, so multiply by 0.001. And when you put this in your calculator, you get 199,526.23. All right, you have not answered the question. This is the intensity of San Francisco. You have not answered the question. The question says how many more times than 10 was this in the San Francisco earthquake? And to do this, you have to take Alaska intensity divided by San Francisco's intensity. So 398,107.17 divided by 199,526.23. And when you type that in your calculator, you get 1.995 times more intense. Now, my question is, why are these numbers so big? Why are the intensity numbers so large? Well, think about it. We're talking about an earthquake. Earthquakes are literally the earth moving. Your earth is moving. The plate tectonics are moving. Of course, that would be super intense and would be really big numbers. Make sure you get this in your notes. Pause the video and rewind if I erased too soon. And I want to show something to you. These are solved the same every time. So if you're given the formula, R equals log of x over 0.001, and you want the x by itself, well, let's solve for it. The common understood base is 10. So 10 to the magnitude on the Richter scale equals x over 0.001. And then you have to multiply by 0.001 on both sides. So x equals 10 to the magnitude times 0.001. Well, look here. That's what you did each time. Whoops, I erased it. But that's what you did each time. So this is a formula for intensity. This is intensity. And this is Richter. All right, page 433, number 43 says, the 1985 Mexico City earthquake had a magnitude of 8.1. The 1976 earthquake in Tangshan, China was 1.26 times as intense. What was the magnitude of the Tangshan earthquake? I think I'm going to save this one for class. I'm going to do that one in class with you. This one, however, I'm not. The decibel scale. That funky looking letter is beta. It's a Greek letter, but we're just going to call it B. B equals 10 times log of I over 10 to the negative 12. 10 to the negative 12 is the intensity of a barely audible noise. This symbol is the intensity level in decibels, and I is the intensity level in watts per square meter. So I is intensity level in watts per square meter, and B is the intensity level in decibels. So they're both talking about intensity, but it's a different kind of intensity. So page 433, number 45 says, the intensity level of the sound of a subway train was measured at 98 decibels. Find the intensity in watts per meter squared. So we're talking about decibels, so I need to use my decibels formula. Okay, I gave you decibels, so I have to put that in the decibel spot. 98 equals 10 times the log of I over 10 to the negative 12. Okay, I needed to get the logarithm all by itself. As of right now, it has a 10 in the front, so I need to divide by 10. And 98 divided by 10 is 9.8. And you have to know the understood base for a log if it's not written, and that is 10. So you do your cycles. 10 to the 9.8 power equals that. So 10 to the 9.8 power equals I over 10 to the negative 12. And now you know how to get I by itself. You multiply by 10 to the negative 12. Slow my video down if I'm going too fast. That cancels out. And when you type this in your calculator, you get 0.00631 watts per meter squared. And that's the answer. Now, I want to mention these are solved the same way every time. So if you're given decibels and you want to find intensity, there's a formula for that. Here's decibels equals 10 times the log of I over 10 to the negative 12. And you need to get I by itself. Well, first you divide by 10 on both sides. So you get the decibel divided by 10 equals the log of I over 10 to the negative 12 power. You need to get rid of that logarithm. You know the understood base is 10. You do your cycle. So 10 to the equals I times 10 over negative 12. And now you just multiply by negative 12 on both sides. So the intensity in watts per meter squared is always equal to 10 to the negative 12 power times 10 to whatever your decibels were divided by 10. Always. Thank you for watching my video.